Okay, this morning we stop at this extra homework. Okay. Just move forward. Okay. If no question about this morning about moment. Okay, moment. What does it mean? Is always moment and positive anticlockwise equal 0. This is in equilibrium. Okay. And the definition of moment, you always have an axis. And if there is a force from a reference point O, you find the perpendicular distance of T, then it will generate moment. Okay, moment at O. Okay, the equation will be M equal to Fd for the moment. Unit will be Newton meter. Newton not meter. Okay, this session we only have 1 hour, so we go into cross products. Okay, earlier, chapter 2, we have dot product. What I mean by dot product? A dot B equal to AB cos theta, also equal to AX BX plus AY BY plus AZ BZ. Okay, so this is vector, and it becomes scalar. Becomes scalar. Yeah. So now we learn about cross products, which look like this. So the products of vector A cross B will equal to C. The cross products. Okay. This one, when you do right hand rules, if you do cross, means you find the relationship between A and B. When you want to make A cross to B, you will generate a direction with the thumb labeled as UC going up. Okay. Magnitude will be, the magnitude of this cross product will be AB sine theta. Okay. So cross product a bit different from dot product. B equal to A cross B equal to AB sine theta. Okay. Dot product, when we apply, dot product when we want to move, we want to combine two vectors together. Got it? Okay, we want to combine vector A, vector B, multiply two vectors, means you multiply the two vectors together. You get this one. So if you don't have this multiply with the same axis, right? You put in the same axis or same line. Then you use, if you have an angle between A and B, then you use cross products. Okay, so for example, the one you see on the screen here, this is B, this is A, with the angle theta. So you want to combine these two with the angle, it will generate one more axis, is called C. In this case, follow your right hand rules. It will be anti-clockwise if you view from the top, right? Okay. So this is an application between two. One is the dot product. Dot product means you want to put two vector aligned together. Okay. If you want to put the two vector in with the angle, you want to put together, and then you use cross product. So these are the differences between two. So don't confuse between that, both of them. Magnitude, also a bit different. Magnitude, you use sine theta, AB sine theta. I skip the derivation mathematically from here to here because more important, you know the application. Okay, C equal to AB sine theta. Angle still same from 0 to 180 only. Okay. Direction, follow your thumb. Direction, follow your thumb. Okay. So again, A and B is happen on the plane. A and B happen on the plane, and your right hand is on top of the paper. And depend on the either A, B, or B, A to B and A to B, or right. So it's important the sequence. The sequence when you cross, use the cross is sequence is important. A to B will give you pointing up. If you write B cross A, it will be flipping direction already. Because B cross to A, it become like that. So it will pointing down already. Okay, so direction will be different if you use cross, but however, dot product will still remain same. Yes. Okay, so this is a different. So just be careful when you use cross. Okay, so how do you know when you need to use A cross B or B cross A? Always follow your thumb. When you want to calculate something, follow the thumb. So if the question you see A and B, so just look at your right hand, and you just cross A to B to find the correct magnitude. Okay. So this is a vector. This is a scalar. Magnitude means the one that you can measure. Magnitude. So vector, you have magnitude and direction. So if you write in the vector form, you write in C in the vector form. C is a product of A cross B. So C itself is a vector. Vector and magnitude and direction. So you write in the vector form will be vector. Magnitude is AB sine theta. Direction is UC. So C is a vector. Vector have magnitude and direction. Okay. C, if you do cross, is the product is vector. If you use dot, dot becomes scalar already. Dot becomes scalar because you are multiplying two vectors together. It becomes scalar. Right. So cross, it becomes vector. So these are the differences. UC, again, how to find UC in the question? You need R to find the UC, to find the U. U is unit vector. You need the R. Okay, revision. How to find U? U equal to R divided by magnitude of R. Okay, this is a vector. Okay, however, if this is U, means it's 1, vector is 1. Okay, unit vector is always 1. So actually, you just copy back the vector because this is 1. Okay. Okay, law of operation, this one I think you know. You cannot flip A and B, B and A, cross is different. So accumulative law is not valid. So for dot product, there's an accumulative law. There are 3 laws in the dot product. Go and see the slides, right? But for cross products, it's different between A and B, B and A. The direction of your thumb is different. The direction of the vector, the product of the dot, the cross vector will be different. One is pointing up, one is pointing down. Depend on where you count. Okay. So you can write something like this. If you want to change the equation, you want to flip the A and B sequence, you need to add negative to the vector. Okay, A cross B, A cross B. Okay, A cross B will be pointing up. Equal minus B. What is minus B? Means if this one minus, means this one flip to this direction. This one flip to the other direction, and is minus is A cross B again. So is negative. So negative. Yeah, but anyway, you just put negative there. Okay. So yeah lah. So this if cross product is multiplied by a scalar, so it is apply the scalar method. So you multiply some value in the bracket, the cross. So again, you are actually A cross B is a vector, so you cannot pull this vector that multiply 2 times. It's not fair for the resultant. Okay, so if you have a value to multiply the products, you only can carry forward one into one of the vector. Okay, so the sequence also doesn't matter as long as you bracket it. So cross product also obey the addition law. So if you A cross B bracket A plus B actually is addition vector. So when F vector is still the same magnitude, same resultant. So you can multiply across A cross B plus A cross D is the same. So these are the 3 rules for when you want to use cross product. One, A cross B not equal to B cross A, but if you want to put them equally, put negative in either one of the vector. Okay. Then if you have the scalar, then bracket, remember you only can multiply one of the vector. If you have cross bracket plus 2 vector, you can do cross products. You can split into 2 cross products. Okay. Okay. Another one is vector analysis, Cartesian analysis. When you see the vector analysis, means you need to call the ijk already. So ijk, I cross to j, your right hand rules. I means x direction, cross to j, you will get z direction. Z direction is k. So k equal to I cross j. This is what you learn in vector, right? So I cross j, it will equal to AB sine theta. Just remember there's before C equal to AB sine, is C equal to A cross B. C equal to A cross B equal to AB sine theta. So you just skip the middle part. Straight away, you take AI cross J equal to IJ sine theta. What is sine 90 degree? The angle between I and J always 90 degree. So sine theta equal 1. Okay. So I magnitude is 1, J magnitude is 1, sine 90 is 1, so you get 1. So I cross J, you get 1. So the resultant direction is K direction. Okay, so AB equal to 1 in K direction. So this formula is to get the magnitude. Is to get the magnitude. So vector, you have magnitude and direction. This is to get the magnitude. So that's why you get 1 here, and then the direction is K direction. Okay. Cross product always get a vector. Vector have magnitude and direction. So similar, you can do the same. I cross J equal to K. And if you do J cross K, J cross to K, your hand J cross to K, you get I direction. I direction is positive this direction. That's why you get positive I. And K cross I, you get J direction, positive J. How you get negative J when you take I cross K, I cross to K, you have to do like that lah. I cross to K is pointing inside negative. going against the y-axis, negative j. Okay, j cross to I, also you need to flip your hand a bit. Okay, j cross I pointing down, and positive go up, so you get negative k. Okay, negative k. Why negative a? In front of the negative actually got one, actually got one value inside, because why? Magnitude is AB sine theta. AB is 1, 1, sine 90 is 1, so you get magnitude of 1. All this got 1, 1, 1, 1 in front. I cross I is 0. Why? Why 0? I, no direction of crossing. No direction of crossing, 0. A bit different from the dot. Dot I equal 1. I dot j, I dot k, 0. Don't confuse with cross and dot. Okay, there is a diagram to help you a little bit. You remember, you can draw this diagram anywhere in your workout. You write I, J, K, draw a circle. If it's anti-clockwise, because your hand is anti-clockwise. If it's anti-clockwise, circling like this, you get positive value. If it's anti-clockwise, like this, anti-clockwise, you get negative. So by drawing this diagram, anyhow, you get the answer. Like for example, you take J cross K positive direction. J cross K, you get I, positive I. Then K cross I, you still get positive J. So for example, you take J cross I, clockwise, you get negative K. You take K cross J, you get negative I. This diagram is important. If you cannot remember all this, use this diagram to help you. Okay. So today your homework will be this one. Draw this one. I, J, K, anti-clockwise positive, clockwise negative. Okay, so if you take A cross B, I don't expect you to derive all this, but I just explain to you so it makes sense. A cross B, it means you take A vector can split into ijk, ax, ay, az, ijk, cross bijk, and so on. Then you do multiplication one by one. A cross B, A, okay, the first one. You take AXI cross BXI equal, how to find magnitude? AB sine theta. So you get AX BX sine theta 1. Because, sine 0. Sine 0 is, because I to I, I to I, no angle, so 0. So you get 0. But you will still get here, BX, AX, BX bracket, I cross I. You do the same for the rest of 9 components. But you know what, from this diagram, I cross I 0, I cross J 0, I cross K cross K 0. You can add a little bit here, 0, 0, 0. Okay, so you can cancel. And the rest you rearrange. For example, Ij, you get K, Ik, you get negative J, Ji, you get negative k. Jk, you get positive I. You get the product of this, then you rearrange in ijk. You'll get this form. Okay, you get this form. So there's another formula to remember beside the circle ijk. There's another, if A cross B equal to that lengthy equation I plus J plus K. So you take AZ, BZ, AY, BZ minus AZ, BY, I minus AZ, XZ, BZ, and so on. Okay, all derived from this equation. This equation won't be given. So we expect you to memorize it.
So the cross product, it only occurs in the three dimensions,
IJK.
right?
Yes. Yes.
Possible to occur in the 2D plane. If you like disregard, for example, one of the planes, it won't be possible.
That one, another chapter already. It will be a very complex issue, problems. It also under vector, but it jump outside this one already, because you already have this, the sine theta. The theta will have some angle with alpha, beta, gamma. Then it become very complex vector operation. For static, we don't go deep into that that complex mathematics, unless you take astrophysics, you take those dealing with aerospace, all these things. Then this one will be, or electromagnetics, wave, or all this. Then they will have this one. Okay, now it may be very difficult to look at this, so conveniently convert this one in matrix form, then it's more easy to remember. A cross B equal to matrix of 3 multiply 3, 3 please plus 3 matrix with, you write I, J, K, and you write AX, AY, AZ, BX, BY, BZ. I hope you remember how to do matrix. This one equal to matrix form 3 by 3, I, J, K, A, and B. X, Y, Z. Okay, I demonstrate one time how to get this one. You want to get I, you put your finger there. Then you only have what? You only have J and K. So what do you do? A, Z, what? A, Y, B, Z. A, Y, B, Z minus A, Z, B, Y. You get I. Okay. Means if you want to find I, you cross this one. You put your finger there. Then do cross. AZ, AY, BZ minus inverse diagonal, means you do like this. You do this motion. Okay, so you don't need to remember this very complex form. You remember matrix form. So after you done I, you move your hand to J. Means you're pointing to J. So how to do? Also cross. Cross, then like you're doing like a fish shape. AX multiply BZ minus AZ and AX, like you U-turn. You U-turn means you negative. Okay, you get this one. That's why negative there. Negative. Okay, it's negative. J is because what? It's negative because what? You are taking what? I cross K. From this circle, I cross K, you get negative J. So don't assume it all positive. So when you do this one, when you cross, you want to do J, remember this circle. You are taking, how to get J? You take I cross K, I cross K, I cross K get negative J. So it's important you write the negative magnitude first before you do the matrix. So AX BZ minus AZ BX. Then you want to calculate K, right? How to get K? I cross J. I cross J. I cross J positive K. I cross J positive K because anti-clockwise. So I cross J, you take AX BY reverse negative AY BX. You get K. So this is an important matrix that help you to solve in many questions that link you with cross products. The question will force you to use this one by mentioning determinant form. Put your calculation or put your solution in or by using determinant form. Means the question will force you to write this one. But actually it's a guide you to solve the question, just in case you forget. So you see the determinant form in this one. This one, you write this one, got marks already. If you forget how to do that, another story. Okay, you draw this one also no marks. You draw this one no marks, but it will help you to find positive, negative. But this one, yes, this one got marks. Okay, so this one I hope is useful to help you. Okay, this one is the notes lah. How to find the things. I just put it just for your notes lah. Okay, just for your notes. Just remember negative sign and so on. Okay. So we are done with the cross products. Then we go into application of products, cross products. What is moment? Right. So moment. Why moment? Because you are taking force multiplied by the displacement. So two vector here, R vector, F vector. Although in the secondary level or in the foundation, we tell you this is the distance. It's actually a vector from a point. Okay, it's a vector to a point. With the distance you see 90 degrees in that direction. Okay, so R must be perpendicular to the force, then it will form moment. Okay, the force in this direction perpendicular to the R, you will form this one. Remember, we have seen a few contacts, I think this morning or yes, previously. Three contact, you see spring. Remember spring? F equal to K. You see spring already, we write KX or KX, doesn't matter. You see spring already, you write this one. You see rope or pulley, you write T. Then you see what? You see what already? Got one more. Sphere. Sphere got one contact point, which is always normal to the this one. Okay. And this morning also we learned moment. Moment when you have a plane, the R will always perpendicular to the force. Okay. It happen at one point because round body contact with one point. Okay. And always tangent to the curve. Right. So 90 degrees. So same. This one, just to remember you are actually taking the R vector and F vector. Okay. So moment of the F at O, you can use vector form by taking R cross F. R cross to F. Right hand rules again. Your R actually following the F. R cross to F. R cross to F, you get moment. Okay. So pointing up, cross, you get anti-clockwise direction. It's different. If you take R, if you take force multiply cross R, it's a different. If you take force cross R, means it's negative moment already. Go down. Okay. Okay. So just stick to the mind. You for moment always write R first, then force. R cross force. Okay. R cross force. How to find magnitude? Okay. Again, magnitude for crossing is you get a C because this is A cross B. A cross B equal to AB sine theta. So now your A is R, B is F. So you get RF sine theta. Okay, just apply what you learned like 10 minutes ago. Right. So you just apply this one, RF sine theta. So again, because moment, how you create moment, these two must be perpendicular. So angle will be 90. So 9 sine 90 equal 1. Okay. In this case, it just give you something that is with an angle. This diagram will assume we have a 90 degree, but what if the force is not 90 degree to the R? Then you need to find the D to find the moment. So in this case, you have a theta with the force direction. There's a theta there. So you need to create one right angled triangular there to find the D, because this D will give you the moment. This F multiplied by D, you get moment. Okay. So D equal to, if you look at this triangular, D equal to cos or sine. If you have R here, you want to link R and theta with the D. So it's a sine. It's because it's a opposite and hypotenuse. Okay, so you put the D because we want to join back with what we learned this morning. So moment equal to R F sine theta. This is the magnitude. Magnitude equal to FD. Okay, so this is the agree lah. It's agree with what we learned this morning, and the cross product also. This is how we get the AB sine theta earlier. So it's agree with this by using this diagram. It just makes sense. However, we won't ask you to derive the equation. We just let you make sense. Or okay, actually it makes sense that I get moment equal to FD, and if I have vector, cross vector, I take R cross F, I get RF sine theta. It just want to explain to you it makes sense. Okay. So R must be treated as a sliding vector so that theta, sorry, this one theta can constructed, this is theta type of error, theta can be constructed properly. Sliding means is it's just a name. Actually, it's just a name. Okay, direction is the same. It's the same. Okay, so if you sliding vector means you can extend the vector a little bit. Okay, this is the direction of R. So no matter short or long, is still that direction. So you extend this direction. So when you do cross products, R cross to F, okay, you do R cross to F, you will get the right hand rules properly. Okay, so if you see question with the force in this direction, with the R, with the angle, what do? You extend the line first. You extend the line so that you can see R cross F. So first you extend the force line to the back, or you can extend it to the front. Then you extend the R. You extend the R. Then you will see R cross F direction pointing out. This is the trick lah, the trick of doing that. Okay. Before we go into the real problems tutorial question, there are some rules that we need to teach you. Which is the principle of transmissibility, means you can transfer the force somewhere else. Okay. The force, the force have force is vector. Vector have magnitude and direction. The direction of force always following a line of action. This is a line of action. So this is the reference point O. Okay. So if this O to the F, if we extend, let's say I extend the R, right? I extend this R arrow to forward again. So R cross F, this one, R cross F, I still get pointing up. Okay, so I still get pointing up with anti-clockwise direction. It's the same as I extend this R2 from this location, to the force. I extend this one. So R2 cross F, I still get that direction. Same with R3. R3 cross F, I still get pointing up. Yes. Yeah, I mean, this is 2D, so you see it as a 3D lah. Okay, so yeah, so again, this is vector. It's not the normal 2D diagram. So 2D one, yes, you can equal to F cross D, the distance, but this one is R. R is the vector direction to that force. Meaning you stand here, you look at that direction, cross with the force, that will get moment. It's like you throwing a rope to catch the force. You still feeling the same moment. Still feeling the same moment. So this is the transmissibility, meaning you can change the location of R without changing the line of action of force. Okay. So since force can apply at any point along the line of action and still create the same moment about the point O, then force can consider it as sliding vector. Means you can put your force at the back or in the front, as long as you didn't change your focus point O. As long as you stand here, you can see the force. The distance of R is changing, never mind. As long as the force is along this line of action, you're still creating the same moment. Okay. Okay, so this is to highlight the force you must maintain at the line of action. Then your moment won't be changing. You fix the line of action and where you stand or the focus point. Then you're still creating the moment. This is called principle of transmissibility. Means you can move the force front and back. Okay. So means if you move your force along this distance, you need to align lah. You need to align with the R2 or R3 properly lah. Okay. Again, this one we won't test you, but we will apply this concept in the tutorial question. Okay. Next one is what we will see in the question. You look at axis X, Y, Z, and then you will see R and F. Means you stand here, you look to the force. There's a R direction of observation, R and F. So if you extend the R, the R line, you will be crossing force, right? R cross F. If you extend this line, you put your hand there, you R cross F, you will get you pointing out of the screen. So this line will pointing out of the screen. Then you'll get moment anti-clockwise this direction. Okay, this direction. So this is just an expansion of this diagram. Here become a more detailed diagram. So what is the difference between the left-hand side and right-hand side? It's just that you maintain the R, but you change the force, the vector of force into x direction, z direction, y direction. Means you split this resultant, this black color arrow, into 3 different arrow in x direction, in y direction, z direction. Then also you have R. R also you can split into z direction, x direction, and y direction. Means you split 2 vector. Because R is a vector, vector have magnitude and direction, you can split into ijk. Force also vector, you can split into ijk. So maintain this point, split F into x, y, z. Maintain this point to the R, you can split into x, y, and z. Okay, so you have 6 from 2 resultant vector, R and F, into 6 component vector. Each one split 3. Okay. You get this matrix form again. M at O will equal to R cross F, vector R cross F, equal to matrix form. You write ijk. This one is the position vector R, R, Y, R, X, R, Y, Z. Bottom one is force. Fixed already. Because we want to get moment, we always get R cross F. R always in the middle, force always in the bottom. Then you know how to use this vector, this matrix already. You want to get I, put your finger here. Then bracket Ry Fz minus Rz Fy cross bracket I, positive I, because J cross K, you get positive I. Move the finger here. J, you take I cross K, negative J. Rx Fz minus Rz Fx J. Move your finger to K. K, I cross J, positive K. So Rx Fy minus Ry Fx K. Okay. So the rest you read. So this is the determinant expanded, you get this form. Okay. So your moment can put in the term of ijk. Your moment is a vector. You can put in ijk form. Because this one is 3-dimensional. So you only use vector or cross products when you see 3-dimensional question. In conclusion, you see 2D, you see xy, you see xz, you see yz. That is 2D problem. 2D problem, you just go ahead and use FD. F multiplied by D. But you see 3D already. Remember this one. Write this one, MO equal to R cross F, then draw the matrix, write IJK, R, and F. This one will come into your answer. Don't worry about this one. Important that you see 3D already, write this one. Okay. Resultant is just you mix everything together. Means if you have like for example 3 forces, 3R, you want to find resultant at O, what you do, you sum up all the force together. Meaning what? You have 3 matrices to solve. These 3 matrix form. We have 3 sets. You need to do 3 sets. Okay? So you in your matrix, let's say this is the first pair, you write MO1, then you do the first matrix, MO2, second matrix, third matrix, and so on. Then you combine together. You combine means you group I to I, J to J, K to K. Understand? Understand? Or it's too complex for you guys? Can I? Okay. Almost time already. Okay. Yeah. So I think I need to explain. Some students start asking questions. Okay, for example, you have that diagram just now. You have this one. So MO1, you get one set, right? Let's say you get one. Let's say you get 10. 10I, 20J plus 30K, or maybe negative. Okay, MO2, you get 20I minus 50J plus 10K. Let's say you only have two. So the resultant of moment will equal MO1 plus MO2. So you group I plus bracket J plus bracket K. So this one plus this one, you get 30. This one plus this one, you got minus 30. This one plus this one, you got 40. You just group the I together. Okay, this is a vector rules. Okay, principle of moment. This one is the same.
The J components of
Ah.
will always be negative, right?
It depends. Yeah, it depends. It's just that when you expand it, usually you will get negative because you are taking something cross something. You are taking K cross I. You'll get negative bracket something, but you might get positive. You might get positive because maybe the radius and force is negative. Means the R and R1 or R or F become negative. Then decon become positive, it will become negative. Or if you do this one, the total number is negative, so negative get positive. Okay. But important is this matrix. You write this matrix, then you only expand. Okay. Then the value of this one depending on the axis. If we go opposite of the R, then negative. Same with the force. If the force in the system or in the question is go against the x-axis, then become negative. Okay. This is just expansion, like the rules that you see just now. You see A cross B, small a. It's the same application. So R cross F, actually, when you expand that force, you can split into two forces in any direction you want, as long as it fit the parallelogram law. So you can split F into F1, F2. So you can do cross products 2 times. This is moment number 1, moment number 2 means you have one set of matrix plus one set of matrix. This is a small forces. Okay, let's do one exercise. You see this one before. It's just that now it forces you to use vector analysis. It forces you to use vector analysis. This one, okay. So use Cartesian approach for this exercise. So this is 2D, but the question can force you to use vector approach by splitting this one into into y and x. So this one is I, this one is j. Okay, so if you see the question force you to use Cartesian approach, write this equation. Write matrix, write MO equal to R cross F, 2 line IJK, R in the middle, F in the middle. Write this general equation first. General equation, don't change anything. Then the next line only you substitute value in. Just in case you write the wrong numbers in this one. This is to safeguard you, at least you get one mark or 2 marks. If you directly substitute, then you see you write the wrong number, 3 becomes 6 or 5 becomes 6, then wrong already. The whole exercise wrong or whole working wrong already. You miss the whole marks. Okay, you write R. R means what? From O to the force. O to the force, it must walk 0.4i and move down 0.2. So you write R curly bracket 0.4i minus 0.2 j. Remember the unit meter. Then about force, also change into I, J, and K. This one 2D, so no K. So force, you split into X and Y. So X is sine 30. Going down is cos 30. So negative because it's go down, because you assume go up positive. So put this information inside this matrix, your K 0, RZ 0, FZ 0. So you write this one, copy, substitute value in. Remember to write 0, 0 here. Okay, so substitute there, and you can see negative value there already. Do the exercise, all right? Or you draw the line, the diagram, this diagram, somewhere just beside the matrix. So you want to find I, right? Close this one. I equal to J cross K. J cross K is JK, J cross K, J cross K, you get positive. J cross K positive. So JK, this one 0, this one 0, 0 minus 0, 0. Right, 0i plus J. You know that I cross K is negative, so negative J, also 0. 0.4 multiply 0, 0 multiply 200, also 0, so 0J. And the last one, K, Ki cross J, I cross J get positive, K. So this one cross this one, negative. Negative, this one multiply this one, get positive. Right, so you must write this one you must write out in your steps. Must write out this one. Then just be careful, your careless mistake lah. Some of you forget to carry the negative. So you get negative 89.6 K bracket Newton meter. This is a vector. Vector had magnitude and direction. Magnitude is minus 98.9. Direction is K. But also you can give the answer in positive value where you flip the direction of the axis. So for example, this one, you get negative K. Where is K? Let's say positive coming out from the screen. Let's say X, Y, and Z coming out. So if you get negative, means the moment axis is going in. Okay. So this is what it means, or you can just maintain like this as your answer if you want. So means negative going in, you will get moment clockwise going in axis. This is the vector analysis. Okay. This one, another one. Another one, also same. You can do it, but this one is 3D. You cannot do using scale. If you want to do scalar, also can. You need to find the angle with alpha, gamma, beta if you want. Right? But try to avoid that. You see this one, you do IJK. Right? So you have two forces there about O here, as placed in Cartesian vector. So first you write the matrix. So MO equal to R cross F, then two line IJK, R, and F. Then you look and see what is force, what is the R, and so on. So write this one as automatic steps. Write this one, then only you substitute value. Write what is R. Okay, so it will be your diagram from this is a question. You should able to see something like this. So what it means, again, you split your forces into direction, and then this one got R and B, got two direction. Your R direction, OA direction, and OB direction. Again, this diagram, it just show you that you have two way of solving the question. Either, because you only need one R and one F, you can either choose O to the tail, means O to A, or you can choose R to the head of the force. Doesn't matter because of the principle of transmittivity. Okay, you can either use R here or RB here, same, create the same moment. Because it doesn't change the line of action for the force. So if you take R cross F, you still get the same moment. RA cross F, still get the same moment like RB cross F. Same, so I just show you this diagram. And the direction, later I'll explain. So if you extend this one, and the force, extend this one, and the force will be R cross F, will be going there. Okay.
So the question in the diagram, they don't indicate for us the direction of R. You can just conclude it's either from O to A or from O to B.
From if the, like this question, it doesn't mention how to find the R, but you know that you always from the O to the force, O to the force. So you have two lines for you to do calculation. So either here to here or here to here. You can pick any line. You can pick any line. R here, R here, R here, R here. Never mind. But in the diagram, you have the fixed value like here to here, here to here. You can calculate by trigonometry. Okay, so because the distance of R can be any place as long as it touch the force. So be smart to choose the more easier way of R. If you want to go complex, or you can find the middle, then you need to break into the many triangular. Don't go there. If you see got the coordinate already, try to use the coordinate. Okay, let's say we use the RA. RA go up, so very straightforward is a 12K bracket meter. So RB, if you want to use RB lah. So RB will be, you need to walk 4 meter to the X, 12 meter to the Y. So 4I plus 12K. Two method. So we now focus on RA. Later we'll focus on RB. You get still the same answer. So let's say your force, you're given small f. Small f means magnitude. F equal to 2 kilonewton with this direction. So you are actually solving using Cartesian vector. So you are right vector equal to magnitude and direction. This one in chapter 2. We keep repeating this one, but we apply in chapter 3. So force vector equal to magnitude plus the direction. How to find U? You use R to find. R vector divided by the magnitude of the R. Okay. I give you the solution, just in case you forget. How to find the top is from here to here. Here to here, you need to walk 4x, means 4I. And here to here, you need to walk 12y. So positive 12j. And you need to move down negative 12 meter. So negative 12k bracket meter. This is the vector direction that is from A to B. The direction A to B means to find the R for UB. Magnitude square root. Okay. So once you find that one, you substitute, you multiply, Okay, this one you get one answer. You multiply inside here, means you bracket, multiply the constant value 2k. You get ijk. You get this form. Means of force in the vector form, magnitude in x direction, magnitude in y direction, magnitude in z direction. Okay, once you have the force, you have the R already. It depends. In this case, we use R to force. So you substitute the value there. In this case, we use RA. RA go up, negative, positive K, 12K. So you get 0, 0, 12 for the R. Then the rest you copy from your calculation. 3 decimal place minimum. If you have decimal place, minimum 3 decimal place for accuracy. Then the rest you just play around with the matrix, with the determinant. Okay, substitute at the end, you get one answer. You can only get I and J without K. Why? You cross I, J, K, you still get some value. You cross J, there's a negative J value. If you cross K, 0 multiply this one, 0 multiply this one, 0, so 0K. Okay, so you can plus 0K, but if you forget to write the K also, I give you correct. There's no K value. So this is how you apply the cross products. Another one is RB so you can look as your extra homework. You can prove you still get the same answer. Sample 6, go and see. Okay, go and see. Okay, then we stop. So, we go to learn what happens if you move the force. Just now we fix the force. Next lecture, we see what happens if you move the force to somewhere else. Okay, we stop here. See you guys next week. Okay, next week.